So good afternoon, honorable students. So good afternoon. So some of you are new today to this class. So am I visible and audible to all of you? Can you able to see my screen? Just let me know in the chat box. Okay. Thank you, Unnati. So let's start with the class. So we are dealing with hydrocarbons. I think for Pune region, hydrocarbons lesson is over. Okay, but you can take this class as a revision class for you, and we will be solving some questions also related to this lesson. Got it? So for the other two regions, Shillong and Hyderabad students, so for us, we have completed the alkanes part, and we are in alkenes now, and in alkenes also we have completed the nomenclature and isomerism and the preparations of alkenes, etc. Okay, so today we will move on with the properties of alkenes. So today we will discuss about the properties. So in the properties of alkenes, we will discuss about the physical properties of alkenes and chemical properties of alkenes. Chemical properties in the sense, chemical reactions of alkenes. Okay, so we are going to see some 7 to 8 reactions under this. The first reaction is the addition of halogens. The second is the addition of hydrogen halides. Coming to the third reaction, it is the addition of sulfuric acid, which is nothing but the H2SO4 addition. And the fourth reaction is the addition of dihydrogen, addition of H2. And the fifth reaction is addition of water. Okay, addition of H2O. And sixth is the oxidation reaction. And the seventh reaction is ozonolysis. Okay, ozonolysis is the reaction with ozone, O3, right? And coming to the last reaction, it is polymerization. So these 8 reactions we are going to discuss under the chemical reactions of alkenes. So moving on to the first topic for today's class, that is the physical properties of alkenes. So the first physical property that I'm going to discuss with you about the alkene is the physical nature of alkenes. Okay, physical nature, whether it is going to be a solid or liquid or gas, that thing we are going to discuss. So now at room temperature means it is 25 degrees Celsius, or in terms of Kelvin, we can take this as 298 Kelvin. Okay, at 298 Kelvin, carbon number 2 till carbon number 4, that is ethene, propene and butene. So these 4 alkenes, they will exist in the form of gas. Okay, then coming to carbon number 5 till carbon number 18, they are liquid. And carbon number 19 onwards, they are solid. Okay, so this is the physical state, physical nature of the alkenes. So it is more or less same as that of alkenes. Okay, so now coming to the next physical property, it is about the colored nature. So most of the alkenes are colorless. They are always colorless, and they don't have smell also. So all alkenes are odorless, but there is an exception, that is ethene. So who is ethene? It is C2H4, right? So ethene is 2 carbon containing alkene. It is having some kind of smell. So ethene has some faint sweet smell. Okay, it is having some sweet smell. And coming to the solubility point of view, most of the alkenes, they are insoluble in water. They are almost insoluble in water. They will not get dissolved when we put this in alkene in water. Got it? And they are fairly soluble in non-polar solvents. So water is a polar solvent. So since all the hydrocarbons are non-polar in nature, non-polar compounds will dissolve only in non-polar solvents. Okay, because we all know like dissolves like, right? Like dissolves like means polar dissolves in polar solvents and non-polar compounds dissolves in non-polar solvents. So now, as I have told you, all the hydrocarbons are non-polar in nature. Alkene is also what? A non-polar compound. So the non-polar compound dissolves only in the non-polar solvents like benzene. So benzene is a non-polar because it also contains carbon and hydrogen. It is also a hydrocarbon, aromatic hydrocarbon, right? So it is a nonpolar solvent. So alkenes are fairly soluble in nonpolar solvents like benzene and ether. Okay, ether is also kind of nonpolar solvent only. There is no complete polarization over there in ether. Got it? So this point you keep in mind. First point is about the physical nature. Second point is about the physical, I mean the colored property. The third is about the smell, and fourth is about the solubility, and the fifth point is about the boiling point. Okay. So as you all know, the boiling point increases with increase in molecular mass. If the molecular masses are different, if the molecular masses are going to be different, then you have to use this relation. That is, boiling point is directly proportional to the molecular mass. The compound which is having the highest molecular mass will have the highest boiling point. Okay. If the molecular masses are same, so where will be the molecular masses same? It will be same for isomers, right? For structural isomers, what is isomers? Can anyone tell me the definition for isomer? Isomers are the compounds in which, can anyone define the definition for isomerism or the isomers? Any of you? Can anyone give a try for the definition of isomers? What about Shivashankar and Priyanka? Yeah. Atomic number, same mass. Atomic number, same mass, different. Okay, Unnati, you have tried and one of you have raised your hand, it seems. Ishwar, yeah, you have raised your hand. Yeah, you have any doubt, my dear? Let me know. Or you want to give me the definition for isomer? Or you have raised your hand by mistake. Okay. Okay. If you're having any doubt, just put it in the chat box. Okay. So I'll go with the definition for isomer. Isomers are the compounds in which the molecular formula will be same. Yeah. Very good. Same formula, but different structure. Very good, Unnati. It is good. You are correct. Same molecular formula, but different structures will be there. Okay, so different spatial arrangement of atoms or different structures will be there. So those compounds are called as isomers. So for this type of compounds in which the molecular formula is going to be the same, for then we cannot use the first relation, right? We cannot use this first relation, right? Because if the molecular formula is same, molecular mass will be same. Molecular mass will be same. So in that case, you cannot use this first relation. In that case, what you have to do, you have to go with the one more relation. That is, boiling point is inversely proportional to branching. So molecular boiling point inversely proportional to branching relation you have to use. Okay, because let me take an example. Not example I can take. Okay, I'll give you CH3, CH2, CH, double bond, CH2. Okay, this is one compound. Now, what is the molecular formula for this compound? It is C4. How many hydrogens are there? 8, right? It is C4H8. Now, let me take one more compound with the same formula, CH2 and CH3. Now, if you see in this compound also has 4 carbons and how many hydrogens? 8 hydrogens. So the formula is same for this. But this particular compound, let me take this compound as 1 and this compound as 2. Okay. Now this compound is having one branch. This compound is having one branch. So this is the parent chain and this is the branch. And coming to this second compound, there is no branching. So it is a linear chain. So the compound which is having the more branches will be having the least boiling point. So you have to go with this relation. Okay. So the boiling point of the straight chain isomers will be more compared to the boiling point of the branched chain isomer. Got it? So these two are the relations that you are learning from the boiling point thing. So the same relation which we have discussed in alkanes also, the same is following here. Okay. So this is about the physical properties of alkenes. So in all these physical properties, the very most important physical property that you have to keep in mind is boiling point, these two relations, and the solubility. Okay. So these two are very, very important. Now I will move on to the chemical properties of alkenes. So if you're having any doubt in the physical properties of alkenes, you can let me know in the chat box. I'll give you some 15 to 20 seconds. If you're having any doubt in the physical properties, just let me know. If everything is clear to you, just type it is clear or yes in the chat box so that I can understand you guys have understood. Okay. Shall we move on with the chemical properties, students? Shall we move on with the chemical properties of alkenes? Yes or no? Yes. Okay. Okay. Thank you. Thank you so much. So coming to the chemical properties of alkenes, first of all, let me show you the structure of ethene. So I have taken ethene as an example. So in ethene, both the carbon atoms are sp2 hybridized, right? So there will be one p orbital and they will be overlapping in the sideways manner to form the pi bond, and this is the pi electron cloud. Okay. So most of the alkenes, if you see, they undergo addition reactions. So why do they undergo addition reactions and what is the reason for that? So the first main reason is the alkene, all the alkenes, they act as nucleophiles. So who are nucleophiles? Negatively charged species are called as nucleophiles. So we represent this as Nu minus, right? Negatively charged species are called as nucleophiles, and the electron rich species are called as nucleophiles. Okay. Now this alkene is an electron rich compound. So what this will do, if I am adding one compound in the form of AB, so in that compound should be polar. The addition compound should be polar. Okay, means it should have both positive end and negative end. Okay. So in that, the positive end will react with the alkene first. So the positive end is called as electrophilic site. Okay, here A partially positive you can see, and this A is the electrophilic site. So since these alkenes are acting as a nucleophile, so always electrophile reacts with the nucleophile, right? So that is the organic chemistry actually. Electrophile reacting with the nucleophile is called as organic chemistry. Now the nucleophilic site of this alkene is going and attacking the electrophilic site of the compound that I'm adding. Okay, and there is one interaction between the compound that I have added, right? So that bond will come and form the bond with the other alkene carbon. So now an intermediate is formed between the alkene carbon and the compound A and B. Now the double bond is broken down between carbon and carbon, and the double bond is acting as a nucleophile here and form the bond with AB. So this is the transition state or the intermediate that has formed. Now the compound will not remain in the transition state or intermediate form, right? Because it will be unstable in that form. So what does it do? The AB bond gets broken down and a new compound like this, that is CH2A and CH2B compound is formed, and this is the addition product for us. Okay. So this is the mechanism. So using this mechanism, we are going to see some addition reactions of this alkenes. So in that only the first reaction is the addition of halogen. Okay, addition of halogen. So I am taking an alkene and I'm going to add an halogen. So all the halogens are represented by the letter X, right? All the halogens are represented by the letter X. So halogens are basically fluorine, chlorine, bromine, and iodine. Now in presence of CCl4, that is carbon tetrachloride, an addition compound is formed. An addition compound is formed in which you can see both the halogens are added. That is, the double bond is broken down and one X here, and add the second X here, you will get this addition compound. And in this addition compound, you can see both the halogens are attached to the neighboring carbon, that is the adjacent carbon. So if two halogens are attached to the adjacent carbon, then that particular compound is called as vicinal dihalide, right? So all these things we have discussed in the previous lesson also, GOC lesson, and in alkanes also I have discussed with you. So basically we are getting a vicinal dihalide on the addition of halogens to alkenes. So halogens are mostly chlorine and bromine. We do not use fluorine and iodine because if you use fluorine, the reaction will be exothermic in nature. Means the test tube or the container in which we are doing the reaction, it may get burst out also because it is highly exothermic. More amount of energy will be released. So most of the case we do not use fluorine. And coming to iodine, iodine containing reactions are very, very slow. Okay. So under normal condition, the product will not form so easily. So iodine does not show the addition reaction under normal condition because the reactivity of halogens decreases down the group. So here is fluorine, chlorine, bromine and iodine, right? So the reactivity decreases on moving down the group. Means the iodine is very least reactive. Iodine is very least reactive. So it is very, very slow. So it will not occur under normal condition. It will occur only at very high temperature or some other alteration we have to do. Okay. And the reaction with bromine, if you see, bromine water, it is used as a test for unsaturation. So what is meant by test for unsaturation? So if I want to know whether my compound is having the double bond, that is a pi bond or not, so I can use this bromine water test as a test. Okay, that is called as a test for unsaturation. I'll explain you this test in detail. So let me take a compound. So first, there is a test tube that you can see on the screen, and that test tube contains the unsaturated compound, and that unsaturated compound is colorless. So in the physical property also I have discussed, no, all the alkenes are colorless. So this compound is colorless. Now, to this alkene, if I am adding the bromine water, I am adding the bromine water is reddish brown in color. Okay. So if I'm adding that, let me add one drop of that bromine water. Yeah. Now it is getting added to that unsaturated compound, and the color of the solution, color of the unsaturated compound is changing from colorless to some kind of brownish kind of color. Okay. Now after some time, the brown color disappears. After some time, the brown color disappears. If the brown color disappears after some time, then we can come to the conclusion that the compound that we have took in the test tube is an unsaturated compound. Okay, that is the compound. This is the compound which is having the double bond. Okay, so that's why the brown color is disappeared. So you can come to the conclusion like this, and you can use this addition of halogen, addition of bromine to the alkene as a test for unsaturation. If the color doesn't get disappear, then it could not be the alkene. Okay, it could not be the alkene, or it could not be the compound which contains the pi bond. Got it? So like this, you can use this as a test for unsaturation. I hope this is clear to all of you. Now I will move on to one question for you. So here is the question. So the starting compound is ethene, and to the ethene, I am adding the bromine, and I am getting a compound A. And compound A on treatment with zinc and on heating forms compound B. We are asked to find out the compound B. Option 1 is acetylene, option 2 is ethylene, option 3 is ethyne, and option 4 is methane. Can anyone try for this? Can anyone try for this question? And let me know the answer in the chat box. Okay, I'll give you some 15 to 20 seconds to solve this question. It is very easy. If you are getting the answer within that time limit, you can put it in the chat box. Otherwise, we can discuss in the class. But I want all of you to try for the answer. Okay, so ethene. So I'll give you the formula for ethene. It is C2H2. CH2 double bond, CH2, right? So take this ethene, CH2 double bond, CH2, and to this answer is option ethylene. I mean option 2. Yes, Sunati, you are correct. Good. Option 2 is the answer. Okay, now let's discuss so that others also can understand. Okay, those who are finding difficult in solving this question, they can understand now. So first we took an ethene and to this bromine is added. How it is getting added? Break the bond and add Br like this, and we are getting CH2Br and CH2Br. So this is a compound A, vicinal dibromide. And this vicinal dibromide is treated with zinc and it is heated. Now this reaction we might have studied in the preparation of alkenes, but we have studied 4 preparations of alkenes, right? And this is the 3rd preparation under that. And here ZnBr2 will be coming out as this, and bond will be shifted here. So we will get CH2 double bond CH2. Okay, this is your compound B, and this compound B is called as ethene. It is called as ethene. The IUPAC name of this compound is ethene, and the common name of this compound is ethylene. Okay, so ethene is not there in the option, so ethylene is the answer for this question. Got it? So I hope this is clear to all of you. If you're having any doubt, just let me know. Now I will move on to the second preparation. The second reactions of alkenes. That is the second addition, that is hydrogen halide addition. So take an alkene, add the hydrogen halide. Who are hydrogen halide? Hydrogen and halogen containing compound is called as hydrogen halide. HF, HCl, HBr, HL. So we are going to add those compounds in presence of same CCl4. The role of CCl4 here is the solvent. You don't have to worry about it. Okay. Now how to add this HX? The same way of the halogen you do here. We have added the halogen by breaking the bond, pi bond, and added those 2 halogens. No, you do it in the same way. Here also, break this pi bond, add the hydrogen here and halogen here. So you will end up with this kind of product. Okay. So here in this product, halogen is added to the first carbon and hydrogen is added to the second carbon. No matter, because this alkene is symmetrical. This alkene is a symmetrical alkene. Okay. So for symmetrical alkenes, you can add hydrogen and halogen in either of the ways, to left to right or right to left. Got it? So what is meant by symmetrical alkene? If I break this alkene, in this part, okay, I will get the 2 equal half. So that's why it is called a symmetrical alkene. So from the symmetrical alkene, we are getting the alkyl halide. So I will show you the mechanism also for this. So first of all, we are taking the alkene. It is treated with HX, and HX is a polar compound, right? Halogens are more electronegative. So they will get the partially negative charge, and hydrogen is giving its electron. So it is getting the partially positive charge. So since alkenes are acting as a nucleophile, it is attacking the electrophilic site, that is the positive side of the HX, and the electrons are shifted to halogen. So here, halogen is removed from HX to give the corresponding intermediate. Okay, what is the name of this intermediate? Carbon is having the positive charge in it. So it is called as carbocation intermediate. Now this carbocation intermediate, if it want to get rearranged, they can undergo the rearrangement also. So where does the rearrangement occurs? So it occurs in the species in which if I'm getting a primary carbocation, on rearrangement of this primary carbocation, if I'm getting the secondary carbocations are more stable than primary, right? So in that case, the rearrangement occurs. So since this alkene is a symmetrical alkene, no such rearrangement is possible, because even if you rearrange the same carbocation, the same primary carbocation, you are going to get. Okay, so no such rearrangement is occurring here. Now, the halogen, which is carrying the negative charge, is attacking the positive part of the compound to give the corresponding product. Okay. So let me show you the example for this. So take this alkene, ethene, and add HBr. So what we will get? We will get how to add this HBr, students. Break the bond, add hydrogen and bromine. In either of the way you can do, and we will end up with bromoethane. Okay. So if I take butene and I add, if I add HBr to this in presence of CCl4, I will get one product, right? That we will get one product. And can anyone give me the name of the product that we obtained from this reaction? Can anyone try for the name of the product that we get from this reaction? So we will break this bond and we will add hydrogen and bromine like this, and we will end up with one product, no? So can anyone give me the name of that product? Fast. Okay. It is 2-bromobutane. It is 2-bromobutane. So all these are symmetrical alkenes. So we can add it in either of the way. So it is 1, 2, 3, 4, and to the second carbon, bromine is attached. So it is called as 2-bromobutane. And what about for unsymmetrical alkenes? And what will happen in case of unsymmetrical? So let me take an unsymmetrical alkene for you. So I have taken propene as an unsymmetrical alkene for you. So if I break the compound with the double bond, I will get two unequal half, right? So it is an unsymmetrical alkene. Now, how the reaction is going to occur? So the pi bond will attack the hydrogen and the electrons are shifted towards the bromine. Actually here, the charge should be partially negative, okay? Now, on this attack, two different types of intermediate I will get. Okay, so one is the formation of secondary carbocation and the other one is the formation of primary carbocation. Because this hydrogen, it can go to this alkene carbon or this alkene carbon. Okay, so two different, if the hydrogen goes to the alkene carbon number 1, I will end up with this particular first intermediate. And if the hydrogen goes to carbon number 2, then I will get the second intermediate. Okay. So the first is the secondary carbocation and the second is the primary carbocation. So two different carbocations are formed. Now, as I have told you, and we all know about this, the stability, right? The secondary carbocations are more stable compared to the primary carbocation. Okay. Secondary is more stable and primary is least stable. Now, Br minus will come and attack the secondary carbocation and it will lead to one product. And in the same way, Br minus will attack the primary carbocation also and it will also lead to the product. Now, both the products will form, but only one will be the major and the other one will be the minor. Now, which one will be the major product and which one will be the minor product? The product or the compound which is formed from the more stable carbocation will be the major product. Okay. So, the first product is the major one and the second is the minor one. Got it? Got it? Now, to find out the major product, we are using the Markovnikov rule. So, what is this rule? It is the hydrogen or the electrophilic part of the molecule that we are adding. Okay. So, the molecule that we are adding is called as the attacking molecule. So, it is getting attached to the carbon which have more number of hydrogen atoms. It is going and attaching with the system which is having more number of hydrogen. That is called as Markovnikov rule. So, in this example, you see propene is there. So, take the double bonded carbon. So, the first carbon contains 2 hydrogen and the second carbon contains 1 hydrogen, right? First carbon contains 2 hydrogen and second carbon contains 1 hydrogen. Now, the electrophilic part or the hydrogen, so it is partially plus and partially minus, right? This part will go to the carbon, double bonded carbon, which has more number of hydrogen. So, first carbon has more number of hydrogen. So, hydrogen goes there and bromine goes to the second carbon, leading to the major product, which is 2-bromopropane. Okay. Got it? So, in case of unsymmetrical alkenes, you add the positive part of the molecule to the alkene carbon, which has more number of hydrogen atom. Okay. So, you don't have to confuse with the mechanism and all. Okay. Just for the understanding purpose, I have taught you the mechanism. Okay. But if you are in the exam, if you are asked to find out the product from the given reactants, just follow this Markovnikov rule. Got it? Now, we have one more rule, that is anti-Markovnikov addition or anti-Markovnikov rule, we can say. So it is also applicable for unsymmetrical system only. So an unsymmetrical alkene is taken, the same hydrogen halide is added, but here you have to use only HBr. So anti-Markovnikov addition will work out only for HBr. So with HBr, we have to add one more compound also, which is called as peroxide. So the peroxide that you can see in the screen is called as benzoyl peroxide. And one more peroxide is also there, hydrogen peroxide with formula H2O2. And if we are adding the HBr in presence of any one of these peroxide to an unsymmetrical alkene, you have to follow this anti-Markovnikov addition. Okay. So what is anti-Markovnikov? It is the opposite of Markovnikov. In Markovnikov, what we have done? We have added this positive part, hydrogen to the carbon which has more number of hydrogen, right? Now you do it in the other way around. You add the hydrogen to the carbon which contains very less number of hydrogen. That is the second hydrogen. So add the hydrogen here and bromine here. Okay. You will end up with this product. Okay. You will end up with one bromo alkane product. Okay. Since we are using the peroxide here, it is otherwise called as peroxide effect. And Karash is the scientist which have found this thing, and so it is also called as Karash effect. Got it? Unsymmetrical alkene with the hydrogen halide leads to Markovnikov product. Unsymmetrical alkene with the HBr in presence of peroxide leads to anti-Markovnikov product. Okay? Clear for all? I'll give you the definition also. So in the presence of peroxide during the addition of HBr to asymmetric alkene, the bromine atom attached to the carbon which has more number of hydrogen atom. Okay. So let us see this or understand this with one more example. C2H5, CH double bond CH2. And this is the unsymmetrical alkene that I have took. And I'm going to add HBr to it. Now how to add this HBr? How to add this HBr? So if you see the alkene carbon, the first carbon is having 2 hydrogen and the second carbon is having 1 hydrogen. Now in presence of peroxide, what we have to do? We have to first break this bond, add a hydrogen here and bromine here. Okay. So you will end up with 1 bromo butane. Got it? So is the Markovnikov addition and anti-Markovnikov addition clear to all of you? If it is clear, just type yes in the chat box. So we will solve one question. Students, is this clear? Shall we move on with one question with this concept? Yes or no? Okay, we will do. So write the final product when HBr is added to 3-methyl-butanene without and with the presence of benzoyl peroxide. So now I have to take 3-methyl-butanene. Okay. To that 3-methyl-butanene, I'm going to add HBr. First is without peroxide and the second reaction is with peroxide. Okay. Without peroxide is Markovnikov addition. And with peroxide is anti-Markovnikov addition. That's it. Okay. Has anyone got the answer for the first one? So first let me do without peroxides. This is 3-methyl-butanene. So this is carbon number 1, 2, 3 and 4. And to the third carbon methyl group is attached. So it is 3-methyl-butanene and add HBr to it. Now without peroxide you have to use Markovnikov, right? So hydrogen is partially positive. And the mechanism goes like this. We are getting a secondary carbocation. We are getting a secondary carbocation. Okay, this is the secondary carbocation. Now, the more stable carbocation, that is a tertiary carbocation, can be formed on rearrangement from this intermediate. How? How does it occur? So the CH bond. So this part is going to the adjacent carbon. Now this hydride rearrangement occurs to form the tertiary carbocation which is more stable than the secondary. Okay. Clear for all? Now to this tertiary carbocation, Br minus will come and attack that tertiary carbocation to give the product, and the name of the product is 2-bromo-2-methyl butane. Okay, 1, 2, 3 and 4. So it is 2-bromo-2-methyl butane. So now why this rearrangement is occurring? Because on this rearrangement, the more stable carbocation is forming. So that's why this kind of rearrangement from 1 to hydride shift. This is the rearrangement is called as 1 to hydride shift. So what is hydride? H minus is called as hydride. Okay. So between this adjacent carbon 1 to hydride, hydride is shifting to give the tertiary carbocation. Got it? So this is the first product for the thing. And coming to the anti-Markovnikov addition with peroxide, if I take 3-methyl-butanone and add HBr with peroxide, I will end up with one product. And you all know that product, right? I have to break that bond. And I have to add hydrogen here and bromine here. So the positive part has to go to the carbon, which has very less number of hydrogen. That is anti-Markovnikov addition. So it will, there is no rearrangement for anti-Markovnikov. Okay. There is no rearrangement here. So it will lead to 1-bromo-3-methyl butane. Okay. So this is the second reaction, that is the addition of hydrogen halide. And in that only we have discussed the Markovnikov and anti-Markovnikov. Got it? Now one more thing I'll tell you. If I have HCl in place of HBr, and also if I have this peroxide, okay, will the product remain same or it will be different? Will I have to use the anti-Markovnikov or anti-Markovnikov? HCl plus peroxide. If I use HCl plus peroxide, so this will lead to the Markovnikov product only. Okay. So only HBr will work with anti-Markovnikov. Got it? So the rest all HCl and HI, even if you have peroxide in it, you have to do Markovnikov addition. Got it? So this one point you keep in your mind. Now we will move on with the third addition, that is the addition of sulfuric acid. So what is the formula for sulfuric acid? It is H2SO4, right? So let us take an alkene and we will try to add this H2SO4. It is concentrated H2SO4 and it is leading to this product. It is called as alkyl hydrogen sulfide. Okay. Alkyl hydrogen sulfate we are getting, and the name of this reaction is electrophilic addition reaction, and it also follows Markovnikov's. So how it is following Markovnikov's? So in this H2SO4, the positive part is H plus and the negative part is HSO4 minus. Now what I have to do? I have to break this bond, add H to one carbon and HSO4 to another carbon. So this part is HSO4. Okay. So it is following the rule like this and it is getting added up. Now let us discuss this with one example. Okay. So you have to find out the positive and negative part. That's it. Rest all remains same. So this is a symmetrical alkene, and to the symmetrical alkene, if I want to add this H2SO4, I have to break this bond and H has to be added to one of the carbon and HSO4 has to get added to the neighboring carbon. Okay. So leading to this type of product. Now, oxygen is forming the bond with this carbon. Why? Oxygen only forms the bond. Hydrogen will not go and form the bond with carbon. Okay. So it is actually HSO4 minus. So it is called as ethyl hydrogen sulfate. Now in the second example, I will take one unsymmetrical alkene, that is propene. And to this unsymmetrical alkene, if I want to add this H2SO4, what I have to do? I have to follow Markovnikov rule, because this propene is unsymmetrical. This propene is unsymmetrical. So now what I have to do? So there is H plus and HSO4 minus here. I have to break the bond and I have to add the, give the positive part to the carbon which has more number of hydrogen, and I have to add the negative part to the carbon which has very less number of hydrogen. That is Markovnikov addition, right? So it follows Marconi-Cups rule and it is forming the propyl hydrogen sulfate like this. Got it? Is this clear for all? Is this clear for all? Shall we move on with the question? Yes? Yes. Thank you so much, Unnati. We will go with one question. So you can see the question on the screen. Which of the following alkene or acid catalyst hydration form 2-methyl propan 2-ol? Option 1, 2, 3, 4. 4 compounds are given to you and you have to find out the alkene that we get on acid catalyst hydration. So what is meant by acid catalyst hydration? So I'm going to add H2O, which is called as hydration, in presence of acid. So this is called as acid catalyst hydration. Now, which of the following alkene will result in 2-methyl propan 2-ol if I add water in presence of H+? Some of you guys have might have already come across this reaction. Only Hyderabad and Shillong region students might have not known this. So other students can answer for this question, I think. Can you try for the answer? Which alkene will lead to this product? Here also you have to follow the same Marconi-Cup addition only. We are going to add the H2O to the alkene. Okay. So in H2O we have H plus and OH minus. So this acid is nothing but the catalyst. Okay. So now you are asked to find out, you have to add this H plus and OH minus to the alkene. Which alkene will lead to 2-methyl propan 2-ol? Has anyone got the answer? Okay, as we don't have enough time, I will go with the answer. It is option 4. It is option 4. So in option 4, if I add H2O in presence of H plus, now how to add this H2O? Since H2O contains H plus and OH minus, I have to follow Marconi-Cup rule because this is an unsymmetrical alkene. So break the double bond, add hydrogen to the carbon which has more number of hydrogens, that is CH2, and add the negative part to the carbon which has very less number of hydrogen. Okay. So this is the compound which will lead to CH3, CH3 and OH and CH3. So this is the final product, right? Now 1, 2, 3. So to the second carbon we have a methyl group. So it is 2-methyl propan 2-ol. So option 4 leads to the given compound. So option 4 is the answer. Okay. Now we will move on with the fourth reaction, that is the addition of dihydrogen. So let me take an alkene. So alkene has CnH2n as the formula. CnH2n is the formula for alkene. And to this alkene, I am going to add hydrogen. Hydrogen is H2. In presence of metal catalyst, that is platinum, palladium and nickel. Now how to add? I will get alkane if I add hydrogen to alkene, right? So very easy. So ethene I am taking, and to this ethene, if you add hydrogen, you will get ethane. Very easy. So if I, the fifth reaction is the addition of water. Fifth reaction is the addition of water. So from this reaction, I have asked you the question. Okay, that acid catalyst hydration question, I have asked you from this reaction only. Okay. For Pune region students, I have asked that question. But anyway, no issues. So now let us add this H2O molecule to the alkene. So H2O contains H plus and OH minus. So since this alkene is symmetrical in nature, I can add hydrogen to any of the alkene carbon and OH to any of the double bonded carbon again. And it will lead to alcohol. It will lead to the formation of addition of water leads to the formation of alcohol. Now you have to add this water in presence of acid. In presence of acid. So that's why the reaction is called as acid catalyst hydration. Acid catalyst hydration. So let me take this alkene and I'll add water to it in presence of H plus, that is acid. Now what will I get? 2-butene is symmetrical. If I cut this molecule into 2 with that double bond, I will get 2 equal half. So it is a symmetrical molecule. So you can break the bond and add the hydrogen in any of the ways like this. Okay. So you will end up with 2-butanol. You can add OH also like this to this first carbon and H like this. Okay. So this combination is leading to 2-butanol. Now, unsymmetrical alkene. Now to the unsymmetrical alkene, we have to use Markovnikov addition. We have to use Markovnikov rule. That is, break this bond, add hydrogen here and OH here. The negative part of the molecule goes to the carbon, which has very less number of hydrogen. So it will lead to the propan-2-ol product. Okay. Is it clear for all? Shall we go on with one more question? Yeah. Identify the major product of the following reaction. An alkene is given to you, a cyclic alkene, and dilute H2SO4. So this is the acid, H+. Acid contains H+, and in presence of H2O, you will get two products. And among those two products, you have to give me the major product. It is very easy. Don't get scared on seeing the reactant. So this is actually the carbon-carbon double bond part. And the reaction occurs in that part only. And let me take this carbon as number 1 and this carbon as number 2. And in the first carbon, you can see no hydrogens are there because this carbon already it has 4 bonds. So there is no hydrogens attached with carbon number 1. And coming to carbon number 2 has only 3 bonds, right? So the 4th bond is hydrogen, carbon-hydrogen bond. Now carbon number 1 has 0 hydrogen and carbon number 2 has 1 hydrogen attached to it. Okay. Now you follow the Markovnikov addition. So where does the H plus and OH minus go? Break the bond, add the H plus to the carbon which has more number of hydrogen. Okay, more number of hydrogen here in this compound, it is carbon number 2. So add hydrogen here and OH here. Add hydrogen here and OH here. You will end up with this product. Okay, OH is getting added to carbon number 1. And to this carbon number 2, hydrogen is getting added. Got it? So the name of this compound is 1-ethyl cyclohexanol. 1-ethyl cyclohexanol. Okay. So let us move on with one more reaction for today. That is oxidation. We will discuss this oxidation and we will close the class. What is the time now? Okay, it's already 3:56. You guys have to go for the next class, right? So I'll stop here. So today we have discussed the physical properties of alkenes. And under chemical properties, we have discussed some 5 reactions. First one is the addition of halogen, addition of HX, and addition of water. Then what is Markovnikov addition, and etc. Right? So addition, all the addition reactions I have discussed with you today. So this is a summary of today's class. And in next class, we will discuss the remaining 3 reactions. Oxidation, polymerization, we will discuss tomorrow. And then we will jump to alkynes. Okay. So thank you so much for all of you for listening to today's lecture. And I will meet you in the next class tomorrow. Okay. Thank you so much, students. Bye-bye. Take care. Yeah, bye, Unnati. Bye.